Okay, 17.1a notes. At this point, I can only upload 15-minute videos to YouTube, so we're going to keep this to 15 minutes. That probably means I got to split this into at least 2 parts, maybe 3 parts. We'll see. Hopefully, today's stuff, this sohcahtoa stuff, is review from last year. Just a little review of it, and we'll extend it and do a little bit more with it, but not a lot of new stuff in Mod 17. Okay, so first of all, hypotenuse. I think we all should know how to identify the hypotenuse. The hypotenuse in this picture that I have here is the side from A to B. It is opposite from angle C. Angle C is my right angle. We usually label this hypotenuse with a lowercase c. Lowercase. Okay, lowercase c opposite to capital C, opposite to angle C. We label all of our parts that way. We label capital B angle, opposite from that, lowercase b side. Capital A angle, opposite from that, lowercase a side. And that's the way we're going to refer to these things throughout the Mod 17 assignments. If it's a right triangle, unless they tell you otherwise, we're assuming C is the hypotenuse, capital C is the right angle, A and B are the other 2 legs, capital A and B are the other 2 angles. So we got to talk about opposite. Opposite means it's not touching that vertex. So we have side AC is opposite to angle B. AC is also referred to as lowercase b, opposite from capital B. CB is the leg opposite to angle A, so we refer to it as angle A. Adjacent means touching. AC, side from A to C, is touching angle A. That is side B. C to B is adjacent leg to angle B, so we call this one the A. For these examples, we're going to use AC is 3, BC is 4, AB is 5, just because I think a lot of us know about 3, 4, 5 triangles. Okay, sine is our SOH. Sine is our opposite over hypotenuse. So the leg that's opposite from A would have to be lowercase a, and the hypotenuse would have to be the C. If we look at this with numbers, A over C, 4 over 5 in this picture. Let's go back and put those numbers on here. A to C is B, which is also my 3. B to C is A, it's also my 4. A to B is my hypotenuse, my C, and this is my 5. We're going to be using those as we work through these problems. Cosine is adjacent leg over hypotenuse. And I know my hypotenuse will always be the C, unless somebody tells me otherwise. And the adjacent to angle A would have to be something that touches angle A but is not a hypotenuse. The one that touches angle A but is not the hypotenuse is my B. B over C equals, in this case, the B was 3, and the C is still 5. Tangent, opposite leg over adjacent leg. The side that's opposite from A would always be lowercase a, even without looking at the picture. The side that's adjacent to A can't be C for hypotenuse, must be B. That's the one that touches angle A, but is not actually the hypotenuse. Okay, so A over B equals 4, I don't like that, equals 4 over 3. That's true for any ABC triangle as long as C is the right angle. If they want to find the angle that goes with these things, we're going to have to do things a little bit differently. The sine of the angle is 4/5. So the measure of angle A would be the inverse sine. We use this little -1 exponent to indicate inverse sine of the 4/5 from up there. You need to use a calculator. For most calculators, we do this by pushing the shift or the second and then our sine button. Watch your calculator. Is your calculator one of those where you need to put the number and then the sine button, or the sine button and then the number? Most of them do the sine button and then the number. We're going to round angles to the nearest tenth. In this case, 53.1. Don't forget the degrees. Okay. If I try and do that again with if I'm trying to do that with a cosine, I have to say the inverse, -1 means inverse, cosine of this 3/5 I have up here. Turns out I get exactly the same answer. Because of course, I'm still finding the same angle in the same triangle. Usually you don't have a choice. Usually you don't know all three sides, so you have to go with whichever ones you have. One more, let's do it with tangent. If they want the angle measure, we use inverse tan. So, inverse tan of, up above here I have 4/3, and again, 53.1, don't forget the degree symbol. Please note that sometimes in our assignment, they don't actually ask you to find the angle. They say find the sine, find the cosine, find the tangent, in which case we just leave those fractions, 4/5, 3/5, 4/3. It's only when they ask for the measurement of an angle that we're going to use that inverse, which means second sine, second cosine, second tangent. And of course, we could look at it from the other angle. We don't have to look at it from angle A. Sometimes we want to look at it from angle B because we need to find angle B. If we want to find angle B, I could say the sine of B, the opposite leg over the hypotenuse, opposite from B, is always B. Hypotenuse is C. Opposite, way over here, opposite from B is always B. Hypotenuse, always C. It's that adjacent. Adjacent can't be C for hypotenuse. It can't be matching because that would be opposite. So if I've got C for the hypotenuse, I've got B for the opposite. This had better be my A. A for the adjacent. It wasn't always A for adjacent, but it is in this case. And then we can use the same numbers we used up above. B was 3. Hypotenuse was 5. A was 4. Hypotenuse was 5. B was 3. And A was 4. Notice that the tangent of A and the tangent of B are just reciprocals of each other. 4/3, 3/4. Look over at sine and cosine. The sine of A is 4/5. The cosine of B is 4/5. Because when you switch from angle A to angle B, what used to be opposite becomes adjacent. What used to be adjacent becomes opposite. Same thing with cosine of A and sine of B. 3/5, 3/5, because what used to be opposite became adjacent. What used to be adjacent became opposite. That is almost a 10-minute video, and I know I can only do 15. So I'm going to move the next section to a new video. Make sure you look for the next video.